let's start with the sixth question. Here you have, in the given figure, so here a figure is given. So in this given figure you have DE is parallel to OQ. So you have DE over here. So DE, which is parallel to OQ, if you observe like this, and DF, which is parallel to OR. So here you have DF, which is parallel to OR, okay, and show that EF parallel to QR. So we must show what? Where EF should be parallel to QR. We must show that. So to show this, firstly let's consider these two triangles, where triangle POQ and triangle POR. Okay, just consider these two triangles. By this we can prove that EF is parallel to QR. So firstly let's draw these both triangles like this. So let me consider like here, let me have a triangle like, okay. Let me take a triangle like this firstly. Okay, consider this triangle as, okay, consider this triangle as P, Q, O. Okay, now to this triangle PQO, where here I have what? E, D. Okay, so DE is parallel to OQ. I have drawn this triangle, just nothing but I have taken this triangle and I have drawn like this. So let this be the first triangle or first figure. Okay, now here let's take the second triangle. So second triangle, here you have POR. Let this be second triangle POR. So just consider here I have a triangle, second one, or a second triangle. Okay, like this. Yes. Let me draw here firstly. Let me draw this triangle over here. So just consider, let's consider this triangle. Okay. Let this be P, Q, O, here like E and D. Okay, where ED is parallel to this. So now let's name it as first triangle, and second triangle here you have, let me draw over here. So let this be second triangle. So where I draw like this. Okay, let this be P, let this be O, let this be R. Okay, if I make a parallel line, if I get like DF. So if you make a look, let this be the second triangle. So if you make a look, you have DF, which is parallel to OR, and DE, which is parallel to OQ. Okay, a parallel side. So now we must prove what? EF should be parallel to QR. Okay, EF parallel to QR. We must prove. So by using these two, we can prove by using Converse or basic proportionality theorem. So first solution firstly. So by using this both, firstly we know that DF is parallel to OR and DE is parallel to OQ. So by basic proportionality theorem, we can say that if a line is parallel, if a parallel line is drawn in a triangle, then the other two sides are of equal ratio. Okay, other two sides are divided in the equal ratio or same ratio. As I can write like, firstly consider these two triangles. So firstly, by considering these triangles, I can say like, in triangle PQO. Okay, just consider this triangle PQO. If I say like, you have DE, which is parallel to QO, right? Then these two sides where PQ and PO are divided in same ratio. As I can write like, by using the basic proportionality theorem, this is like PE by PE by QE. PE by QE equals to PD by DO. Then PE by QE equals to PD by DO. So let this be what? Let this be equation number 1, guys. Let this be equation number 1. So for next, let's consider the second triangle. Here you have the second triangle, where in triangle PO or PRO. PRO. Let's consider second triangle PRO. So here you have a line which got parallel to RO, where DF is parallel to OR or RO. So now if a line is parallel, we know by basic proportionality theorem, so the two sides are divided in the same ratio, as I can write like PD by DR. PD by DR or RD, so DR equals to, wait a minute, here where we know like, here if you observe here this diagram, wait a minute. So if you observe this diagram, you have P, R, O, right? So where in between P and R, where F became a midpoint. Okay, F became a midpoint. As I can say, between P and R, in the side P and R, where F will become a midpoint. Okay, and in PO, here you have D, which has become a midpoint. As I can say, like D has become a midpoint. Done. So here is correct. So now just take like PF by FR. Yes, PF by FR equals to PD by DO. Okay, nothing but by using basic proportionality theorem, I have written like this. So let this be equation number 2. I have just written this triangle over here, drawn this triangle over here. I get like PF by FR equals to PD by DO by basic proportionality theorem. But so in the first figure here you have PE by QE equals to PD by DO. So just write like this. To show EF is parallel to QR, we can relate equation 1 and 2 to show this. So by using equation 1 and 2, as I can take off like from equation 1 and 2, from equation 1 and equation 2, I can take like, so here you have the first equation. Let me write down like PE by QE equals to PD by DO. So here I got what? Equation 1 like this, PD by DO equals to, you have equation number 2. Let me write down like PF by FR equal to PD by DO again. PD by DO, right? So if you observe this equation, you got what? Common. In common here you have PD by DO equals to PD by DO, where this gets cancelled. PD by DO gets cancelled. As I can say like PE, where if I write this, okay, let me write down over here. PE by QE equals to PF by FR. Then we got what? PE by QE equals to PF by FR, right? So PE by QE equals to PF by FR. Now here, okay, so just consider this. Okay, now just consider this. Just look at only this equation where I got. So here, if you observe this triangle PQR, just observe triangle PQR. So So let me draw this PQR over here. Okay, let me draw somewhere over here. Let me draw P over here. Can you see? Here you have PQR. Now just consider triangle PQR. Now if I draw like I got a parallel line. So in triangle PQR I got a parallel line is EF. Okay, I will just take parallel line as E and F. So by this triangle what asked to prove is EF by QR. So they asked to prove that EF by QR, we must show that these both lines as parallel. So if you observe this equation where we got what? PE by QE equals to PF by FR. Right? We got what? When sides are divided in the same ratio. If sides are divided in the equal ratio, then if sides are divided in the same ratio, then the parallel line, so then the two lines which is being drawn will be parallel to the third side, right? So by converse of basic proportionality theorem, we can say that, let me write like, by converse of basic proportionality theorem, I can say right, if PE by QE equals to PF by FR, then here we got what? Where two sides, the ratio of two sides, we got PE by QE equals to PF by FR. So the ratio of two sides are equal, then the line which is drawn parallel will also be equal to QR. So we can say that EF, or if let it be EF, okay, EF is parallel to QR. So by converse of basic proportionality theorem, I have proved like this. Hence proved. I can say like that. Can I say like hence proved? Sorry. Okay.